Researchers have unveiled that a minuscule spot has paved the way for significant progress in nanoprocessing. Today we are going to delve into an exciting discovery made by researchers. It revolves around a groundbreaking technique for laser processing on a minuscule scale, measuring below 100 nanometers. This development holds immense significance for various industries, including automotive, semiconductors, and medicine. The key to this method lies in utilizing a vector beam, also known as a laser beam with radial polarization, which generates a smaller spot compared to traditional beams. To overcome the challenge of field weakening inside the material caused by light refraction at the air-material interface, the researchers ingeniously employed an oil immersion objective lens. With the help of an ultra-short pulse laser beam, they successfully applied this technique to process a glass surface, resulting in the creation of an incredibly tiny hole with a diameter measuring just 67 nanometers. Without further delay, let us now proceed with our in-depth discussion on this remarkable achievement. On March 1st, 2024, the journal Optics Letters featured the publication of its research findings. In various industries, including automotive, semiconductors, and medicine, laser machining plays a crucial role alongside drilling and cutting. To achieve precise processing on a micro to tens of micron scale, ultra-short pulse laser sources with pulse widths ranging from picoseconds to femtoseconds are utilized. However, advancements in technology require even smaller scales, below 100 nanometers, which pose challenges for current methods. The scientists directed their attention towards a vector beam, specifically a laser beam with radial polarization. This particular beam creates a longitudinal electric field at its focal point, resulting in a more compact spot compared to traditional beams. The field of laser processing has been recognized by scientists as a promising technique. Nonetheless, a limitation arises from the weakening of the field within the material caused by light refraction at the interface between air and the material, which restricts its applicability. Utilizing an oil immersion objective lens, which is a typical feature of biological microscopes, proved to be the solution in our case, declares Yuichi Kozawa, a co-author of the paper and associate professor at Tohoku University's Institute for Multidisciplinary Research for Advanced Materials, IMRAM. The refractive indices of the immersion oil and glass substrates are remarkably similar, resulting in the straight passage of light without any deviation. Upon closer analysis of the behavior of a radially polarized beam when it is focused with an annular shape, it was discovered that the longitudinal field experiences a significant boost in intensity. This amplification is a result of total reflection that takes place at steep angles of convergence on the back surface where the glass and air meet. Through the utilization of an annular-shaped, radially polarized beam, Kozawa and his team successfully generated a focal spot of reduced size. Using this technique, they proceeded to utilize a laser beam with an extremely brief pulse to treat the surface of a glass material. By directing a solitary burst of the modified pulse onto the rear side of the glass substrate, they successfully generated a minuscule aperture measuring 67 nanometers in diameter, equivalent to approximately 1/16 of the wavelength of the laser beam. Kozawa emphasizes that this advancement allows for more precise material processing by harnessing an improved longitudinal electric field. This breakthrough provides a straightforward method to achieve processing at scales smaller than 100 nanometers, opening up new avenues for laser nano processing across different industries and scientific disciplines. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.